In this module, we will introduce Apax.NET utility and I/O configuration for ADEN modules. In this training module, we will introduce Apax.NET utility first. After that, we will introduce how to use utility to do DIO and AIO configuration for ADEN modules. Here are the objectives you are expected to understand in this training module. In the following section, we will talk about ADEN Apax.NET utility. This is the software we use to connect and configure the ADEN modules. Let's see what is ADEN Apax.NET utility. It's a graphical interface for users to configure all ADEN series remote I/O module. Users can use utility to connect ADEN modules and send command to monitor or control ADEN. This is how the utility pages look like. After connecting the module to the computer either through serial or Ethernet interface, users can use utility to control or monitor their ADEN devices. The operation windows consist of 4 areas: the menu, the toolbox, the module tree display area, and the status display area. As shown in this slide, I can control the AO channels of ADEN 4024 and make it output the voltage of 2.142 volts. Let's talk about how to configure RS485 device in utility. Here are 3 key factors to establish connection in serial RS485 network. First, we have to know the device ID of ADEN. If there are 2 devices with same ID, utility can only detect 1 device. Second, know the baud rate for RS485 communication. If the controller uses baud rate at 9600 bps, then ADEN need to be configured to 9600 bps as well. That's because we need to use the same transmission speed both on controller and receiver for communication. If the speed is different, sender and receiver cannot communicate with each other. Last, we have to know the correct serial data length. In other words, it means each package size has to be same. If each package of the controller is 10 bits, 1 start bit and 8 data bit and 1 stop bit, then the slave also needs to follow the serial data format to have same package size. This is because both slave and master need to use the same data format. Otherwise, slave cannot understand the data, and we will have trouble when communicate with master due to different data format setting. There is the initial mode, normal mode switch for ADEN 4000 and 4100 series in the middle of this slide. If you are not sure about the address, baud rate, serial data length, and protocol of ADEN serial I/O module you have in your hand, you may switch to initial mode for further configuration. After setting the switch to initial position, you have to power off and power on to configure the module to initial mode. For some ADEN 4000 series without switch support, user will need to manually close initial pin with ground pin in order to enter initial mode. When the module is in initial mode, the setting will be 9600 bps for baud rate and N81 for the data format. In initial mode, there will be a star sign beside the module name under COM sections. User can define the address, baud rate, and protocol of ADEN module in initial mode. When the module is set at initial mode, module address is always 0. The available address for normal mode are 1 to 2055. If utility detects a module with star sign, this indicates this module is set to initial mode for user to do the further configuration on this module. If utility detects a module with device ID, this indicates this module is set to normal mode and with the protocol you configure in initial mode. By the way, if there are more than one module is set to initial mode, due to the device ID are all equal to zeros. Utility can only detect one device. Please configure ADA module one by one to avoid device ID conflict in same RS485 network. The minimum scan interval is 100 milliseconds for the utility. The screenshot is the default setting. If ADA 4000 modules are under different setting, not 9000 and the 600 bps and N81, user have to change the COM port setting here to match the modules. Let's see how to configure Ethernet module. If user want to control ADA 6000 or 6200 series by using utility, the module must work in the same network. For new ADA module, the default IP is 10.0.0.1. User can start to configure ADA module after setting their LAN card in the same network domain. As you can see, all modules in the same network domain were shown in 10.0.0.99 in this subnet. And by the way, there is no initial mode for ADA 6000 and 6200 Ethernet module, but we have the reset button to reset to the factory default. This slide shows how utility find ADA module by sending a UDP broadcast package. When user click the search button on utility, it means the UDP broadcast package is sent to all modules in the same network. As you can see, the source IP is PC's LAN IP, and the broadcast package is sent to all devices in the same network domain. The destination IP is the broadcast IP address for the 4255. And the 10.0.0.51 is ADA module's IP, which use UDP unicast to reply the host PC. Sometimes users open the utility before they set their internet card setting for like the IP subnet mask default gateway, so the utility cannot get the latest network card setting. At this time, we need to refresh it manually. Just follow this screenshot in the slide. The minimum scan intervals is 100 milliseconds, and the supervisor password is that user can set a default password for the module login. Connection timeout, send timeout, and receiving timeout. We usually don't need to change these parameters under normal network environments. There are DHCP and locate function on both ADA 6000 and 6200 Ethernet modules. We provide both static IP and DHCP setting for user to configure the ADA modules. When using DHCP mode, it is hard to identify the module by its IP address. So the locate function, the LED blinking, is designed to help user find the working module easily. In the administration setting menu, user can restart the module here or reset to factory default. This restart function is only in Ethernet module. We can not only change the password but also reset it into 8 zeros in the administration page. In firmware setting menu, user can select firmware, a JavaScript file, HTML file, and so on in upper section. Use the browse button to load the file and click download to download the file to ADA. User can also export configuration file in the button section by clicking Save As button to define the file path. The access control menu is to define the module access right for different users. User can set IP address or MAC address to define which controller have the access right on ADA module's I/O value. This design offers certain security on whether the user have the right to monitor or even change the I/O value of ADA module. The group configuration function can help you to configure all settings to multiple modules just with one click, which means user can configure many modules at one time. Here are the steps to do the group configuration on ADA modules. Right-click on Ethernet icon and click on the group configuration task. Choose the configuration option and select the correct I/O module. Then load the corresponding. Here are the steps to do the group configuration on ADA module. Right-click on Ethernet icon and click on the group configuration task. Choose the configuration option and select the correct I/O module. Then load the corresponding configuration file to this window. Check the module you want to configure, enter password, then click Apply. After the general configuration introduction for ADA, we will move on to the I/O configuration in Utility. Let's see how to configure ADA's DI/DO channel first. There are three functions user can configure your ADA DI modules. First one is DI mode. It is the normal on-off signal input. In this mode, the DI channels of ADA can sense the switch status. It can be dry contact or wet contact. The second one is counter input mode. The DI channels can detect how many times of the DI status change in this mode. In other words, the counting is based on the number of pulses received. For example, user can use ADA module to detect the checkpoint status on the product line. The last one is frequency input. In this mode, ADA utility can help you to calculate how many pulses generate and send to the DI channels of ADA in certain period and convert it into frequency. Here are two examples of application for digital input. First one is DI mode. It can be used to monitor the door status by using the DI sensor installed on the side of a door. The second one is counter input. As you can see, you can use the IR sensor to achieve the object counting on the conveyor belt in the factory. Here is the zoom in for observing the DI sensor signal change when the object is passing by. Please see this demo video. Let's see the DI input function in Utility. In DI mode, Utility supports digital filter function. User can define the minimum acceptable signal width based on their application. The filter function can also help to remove high-frequency noise coming from the DI sensor. As the waveform diagram shown here, when you set the minimum low signal width of 15 milliseconds, then ADA will wait the low signal continue to 15 milliseconds, then become logic low status. For maximum high signal width, it is the same. ADA will wait the high signal continue to 10 milliseconds, then turn to logic high status. So the waveform after DI filter will become really smoothly like below. The other function is invert signal function. If DI status LED on means logic high, when you invert the signal, it will make the DI status LED off, and it also becomes logic low. By clicking the function, the logic of DI will be inverted, which means the logic definition for both dry and wet contact on product spec will be different. For example, in dry contact, the logic is 0 when the signal is close to ground for some of the modules. But after you invert the logic, the close to ground signal becomes logic 1. The open signal will also change from logic 1 to logic 0. Previous in the slide, we have mentioned that the eye can detect normal on-off signal input. Here we take ADEN4055 as example. As shown in slide, dry contact short the ground to the eye, while wet contact short the COM to the eye. According to the eye logic spec for ADEN4055, user will find LED on when he short the ground to the eye in dry contact. Above is just an example of ADEN4055. For every different I/O module, users should follow the different roles and wiring structures shown on the user manual. Here we will do a dry contact hands-on for you to better understand how it works in DI-based module. Below is the dry contact topology. As you can see, it is similar to our first serial debug hands-on in Module 4, but remove the ADEN4561 USB converter and replace the device with ADEN4055. What we are going to do is provide a DI dry contact signal on ADEN and see the logic status of DI LED change on both module panel and utility. If you have some DI module in your office, please do it by yourself. If you have an ADEN module with DIO LED indicators on its front panel, you can test dry contact at your site easily. It is really useful for users to check the DIO status by the LED. Below is the module list, which offers the DIO LED indicators on modules from panel. For serial module, ADEN's 4051, 4055, 4056, or 4150, and 4168. For Ethernet module, ADEN 6250, 6251, 6256, or 6260, or 6266. If you have an ADEN module with DIO LED indicators on its front panel, you can test dry contact logic at your site easily. It is really useful for users to check the DIO status by the LED lights. As mentioned before, DI channel can be used as the counter. The counting is based on the number of pulses received. When setting DI channels to counter mode, every time when the logic status of DI channel change from high to low or low to high, the counter will increase number accordingly. Just like our previous dry contact hands-on, every time the LED turn on will be count 1 in utility. To prevent a power outage may happen, we provide the keep last value when power off function. By enabling this setting in utility, the counter value will remain the same after a power cycle, which can help user to keep counter value when system power is shut down accidentally. If user set DI mode to frequency mode, module's firmware will calculate how many pulses is received on the DI channel per second to get frequency reading. Similar to DI channels, ADEN also support multiple functions in DO. There are 4 modes user can choose for digital output on ADEN modules. First mode is DO mode. User can use ADEN's DO channel to control a device status on/off. The second mode is pulse output. User can define the pulse frequency, duty cycle, high-low signal width on the signal generated from DO channel. Last two are both delay output. User can set delay time for generate high or low signal. For example, delay 1 second and then turn on the LED, or delay 1 second then turn off the motor. Here are 2 examples of application for digital output. First one is normal DO. It can be used to unlock the door to open the door by using together with a magnetic sensor. Second, it can also be a simple switch to be used to turn on a light. The third one is delay pulse output. The application example can be quantitative liquid output control or automatic stop dispenser. As you see in the picture, you can decide to turn off the DO after 3 seconds for the stop switch. It can also be widely used in the factory for many kinds of process control. For example, it can be used to avoid the water hammer effect by close the valve 3 seconds after the pump stops. Let's see the pulse output function setting in ADAM utility. Below is the setting page in utility. User can define the pulse output pattern by their need. Simply speaking, the low signal width and the high signal width can be set. Below is a picture to explain high to low and low to high delay output function in DO channels. While setting DO channels in low to high delay output mode, user can set delay time before generate the high signal from ADAM DO channels. When setting DI channels in high to low delay mode, user can set delay time before generate the low signal from ADAM DO channel. This slide shows how to set DIO mode for each channel. Just click the channel you want to configure, then click the corresponding option in the setting page. Let's talk about the watchdog mechanism in ADAM. The key concept of this function is to provide a safety value on output control module when losing connection with the controller. In other words, the DO channels of ADAM will output a safety value to end device when haven't received any query from the controller. This can ensure the end device is still working properly with the safety value provided by ADAM when there are communication error in the system. For example, when host PC is abnormal, for example, disconnect or not polling ADAM for a certain period. With WDT function enabled, DO will switch to its failure safety value, in short, FSV, user set previously, so the control end device can be protected. The logic status of DO channel will become high when FSV is checked. Otherwise, the logic status of DO channel will change to low. Besides, please remember the host idle time and FSV setting for each channel must be defined before when using WDT function. This is the new function on ADAM 6000-D version for DIO modules, which is called DO diagnostic function. It can detect the DO status of the module. When activating the digital output, circuit wire break or short to ground will result in the failure of digital output. In order to help user to clarify the situation quickly, ADAM 6000-D version are designed with a digital output diagnostic function that is able to detect and respond to the digital output as an abnormal situation. The diagnostic status is grouped as the table we provided in the right hand side of this slide. For more information, you can refer to the FAQ we post on the ADAM forum. Also, you can find lots of information in the user manual. The possible reasons causing the DO channel to show abnormal status could be lots of different reasons, and different modules have different rules. User can refer to the user manual for more information. We provide the status columns on DO channels in the newer version of ADAM Apax.net utility. As we can see here, there are two screenshots which shows the DO diagnostic status of ADAM 6050 and ADAM 6051 on utility. In the left hand side, it shows group 1 and group 2 are abnormal. Since group 0 is normal, it does not show on the utility. In the right picture, it shows all normal. It means all DO channels in the group are connected correctly. No wire break or short to ground before DO are activated. Also, user can get DO diagnostic status from the Modbus address 40307. If the group is normal, the value in the address must be 0. If the group is abnormal, it will store 1 in that address. User can also get the DO diagnostic status by sending ASCII command to ADA module. Here is the simple example in the slide. This slide offers an additional information about sync type and source type for ADA DO module. In brief, syncing and sourcing are the terms used to define the control of direct current flow in a load. Another additional information is about the DO channels and relay output channels of ADA modules. What is different between digital output and relay output? This is a common problem for a beginner in this field. Digital output, generally, it uses a transistor to control device on-off. Relay output, literally, it uses a relay to control device on-off. This table simply shows the difference between DO components and relay. Please note that for the detailed specs for each DO or relay output module, we should refer to the user manual and the datasheet. Let's move to the AIO configuration part. Here is an analog input setting in ADAM utility. As you can see in the picture, user can select different input range based on the application. And please note that only 4 to 20 mA input range have burnout detections. For ADAM modules, there is a built-in 120 ohms resistor for current measurements. User needs to use jumper to switch the input channels between voltage and current mode for AI measurements. For measuring a voltage signal, the jumper or switch on module PCB need to set to voltage mode. If the jumper is set to current mode, the large current will cause the 120 ohms resistor damage. Different modules have different jumper position. Please refer to the user manual before changing the setting. When module used for a long time and become not that accurate, we need to calibrate this module. In ADAM 6217 AE and 6017 CE, there is an auto calibration function for users to do calibration themselves. For some modules, users can calibrate by themselves with the instrument which have a great precision. For other modules, it is suggested to send back to RMA center for calibration. In utility, we have a change log button for user to view real change data, also log its values. User can save the change data into CSV file on their computer. Let's move to AO setting. In utility setting page, user can choose the slew rate for analog output, so the output value will increase gradually based on the slew rate set in utility. This slide introduces two terms in analog output of ADAM module. First, startup output value. User can define the initial output value when module is powered on. Second, safety output value. User can define a safety output value here to prevent controller lose connection with ADAMs. Let's see the digital input function for AO module, especially on 6224. The DI trigger AO function can be used for triggering startup or safety value when DI status change to true or false. And that's all for the Module 5. Thanks for your watching.